Hello again. Can you see my screen?
Yes, we can see it.
Okay. At the start of the meeting, I would like to present the electric generators in watercrafts propulsion systems, structures, durability, and limitations. Electric generators are also very important element of the whole propulsion. And together with reciprocating engines and motors and power converters, they can provide can provide power to the propeller. Electric generator, similar like electric motors, have a lot of advantages. The efficiency can be very high. The voltage can be different, and power also can be various. The voltage can be adjustable at constant frequency. Also, high reliability and durability is possible. Reversibility of work and the maintenance is easy and can provide a long life of the generator. The electric generators are characterized by basic parameters. We can have a generator type. Typically, the generators are three-phase synchronous type, but we can also have other are possible. The three-phase generator need to have a defined winding connection, and for marine applications, the neutral point of the generator is insulated. This is detailed information, but important from the point of view of usage of this generator, comparing to the units used on the land. The generator are characterized by output electric power, reversely as for in motors. They have a rated speed. It's important to provide permanently the rated speed because the frequency depends on the speed, and we need the best frequency if this is an AC generator. Efficiency and other parameters are efficiency, voltage, current, frequency, and power factor. So the generator convert mechanical input power represented by torque and speed via magnetic fields to output electrical power represented by voltage and current. The electric generators are significantly developed nowadays, and due to scientific progress in electrical engineering and related fields like power electronics, computers, materials technology, and manufacturing technology, they can be very modern and meet many requirements. And the efficiency is really high. The main elements of the generator are stator and rotor. Stator is stationary, rotor rotates. Both elements need to contain winding and magnetic core. Additional important element of the generator is excitation system, which provide possibility to control the operation of the generator. The synchronous generator needs to have slip rings, and windings need to have electrical insulation. There is also a mechanical shaft where all rotor elements are located. Additional mechanical elements are bearings, bearing shields, a fan, body with ribs along with transport for transportation purposes of the generator. Also electric terminal box and ceilings. There are various physical phenomena in generators. The generator converts mechanical energy via electromagnetic fields into electrical energy. And there are effects which need to be controlled, joule losses, and we need to depends on the material parameters and magnetic hysteresis. So it's important to use well performed materials with the high properties. Also, it's important to take care about mechanical losses caused by friction in the bearings and aerodynamic purposes and vibrations. Stator design and parameters. The stator consists of the core and the windings. The core is made of a package of electrotechnical steel sheets, and it contains slots in which the winding is placed. Stator parameters are core dimensions, external and internal diameter, length, number of poles, and which defines rotational speed. It can be typically 3000 for 50 Hz or 3600 for 60 Hz for one pole pair. Windings parameters are a number of slots, slot speeds, and pole pitch. So this is detailed parameters of the stator. The generator needs to have an insulation which separates conducting part of the winding and the grounded magnetic core, which is connected with the housing. For a generator below 1 kilovolts, there is just insulation, but for medium voltage machines above 1 kilovolts, we need the insulation system which can withstand electric field potential causing partial discharges. The insulation needs to also withstand temperatures, and there are various classes of insulations. Some typical class is B for 130 degrees, but also other classes are possible, and generator can withstand high temperature. However, we should have some safety margin, and it is recommended to use a suitable thermal class of insulation and sufficient additional margin to provide long life of insulation. Also rotor of the generator has some details, constructional details. The rotor has excitation windings and the core, which is made of steel. Rotors of the synchronous generators can be divided on two types: non-salient polar rotors, where the rotor is cylindrical and the winding is distributed over over 3 of the rotor circumference. Another type is salient type rotor. The concentrated winding is located on individual poles. Both rotors can be used, and there are some detailed differences between characteristic of the whole machines, generators with this type of the motors. And the important element of the synchronous generator is excitation system. The excitation system supplies the rotor winding with regulated DC voltage. In basic system, the winding is connected to the slip ring, which behind the brushes connect the rotor with an automatic voltage regulator system located outside the rotor. There are also advanced non-contact excitation systems with diode rectifier located on the rotor. We can see this in a below figure. Some electronic elements, power electronic elements, are located on the rotor also. And we also have a pilot exciter connected with main exciter by thyristor rectifier. So this is a solution for a brushless excitation system. This excitation system doesn't have a sparks, and it is a significant advantage, especially for operation near to flammable fluids. There are different requirements for marine generators. They need to have a suitable IP code, for example, IP56, IP55. They need to have a high efficiency and need to withstand proper ambient temperature, for example, 40 degrees. It is also required to have a high reliability and long service life, and the generator need to be proof on failures and short circuit, which can happen, and the automatic contact excitation system is now is a standard. Also, accuracy of the voltage regulation is important. It can be plus minus 0.5%, and the temporary need to be proof on temporary voltage deviations. For example, from plus 20 minus 50%. As we already discussed, the generators with engine can be connected as a genset and can generate power, electrical power, providing supply to electric motors. So the genset can be connected parallel, and we need a switchgear to connect all generators, gensets together and distribute the electrical energy. In this figure we can see the system having the tank with the fuel, three gensets, 2 switch gears. We have also energy storage. Parallel operation of generator is possible and can provide advantages. We can control connection of each genset by generator circuit breaker. We can add this power or switch off any unit if it is needed. We have also section circuit breaker and main circuit breaker. So we need to also assure that the voltages of the generators are equal on these bus bars. The frequencies are the same and the same phase sequence when the unit is connected to the operating units. So after checking the synchronization conditions, the circuit breaker of the synchronized generator can be closed. It can be done automatically, where the system can control the time of the connection. During the operation of the genset, short circuit can happen. This failure needs to be detected by the protection system and disconnected selectively. It means when short circuit appear on the left bus bar, we need to the protection system need to switch off the second generator circuit breaker and section circuit breaker without disconnecting next to genset, which will keep the power. And also in this right picture, we see a scenario where the short circuit is on the first terminals of the generator, of the first generator, and then it is important to open only first generator circuit breaker without disconnecting other sources of power. Because then we will have a still possibility to supply unit. Generator protection. So the synchronous generators are protected against various failure scenarios by appropriate mechanical and thermal structure, mechanical protection and appropriate settings of protection relays. The element that plays the basic role in the generator protection is generator circuit breaker, which is adapted to very quick disconnection of the short circuit current. In this photo we can see a marine switchgear with generator with the circuit breakers, 4 circuit breakers. We can also see some control panel. On the right side we see a protection relay, marine protection relay, and controller also with some protection features. Generator protection an example of a generator protection from overloads and short circuit to time current characteristic. We can see the time on the vertical axis and current on the horizontal axis, and we can see if the current do not cause short circuit current do not cause and the protection setting are well set. So the protection need to be fast, as quick as possible. It has around 1 second to open the circuit breaker. It's enough time to do all operation, and normally it can happen within 20 milliseconds or maximum 200 milliseconds. So the generator protection example, we can see functions of the protection. There is a synchronism check function, under voltage protection function, over voltage protection, and over current protection. For bigger generators, we need to have extended functions, more detailed. So the design of generators. Designing of a synchronous generator requires electromagnetic, thermal, and final mechanical calculations. During the calculation, it should be noted that short circuit, the greatest forces and stresses occurred that the generator structure should withstand in a short period of time until failure is turned off. In order to find the optimal structure, design calculations can be supported by final element method analysis. So the generator can be designed with using of computer methods. After completion and when prototype is ready, the generator can be tested, and various tests are described by standards. It's possible to measure winding resistance, insulation resistance. Idle run test is non-load test. It's also possible to do short circuit test, measure characteristic, overload, heating test. Finally, it's possible to determine losses and efficiency of the generator. There are regulations for electric generators. The low voltage and machinery, electromagnetic compatibility, and ATEX directives allows to use CE mark, and there are IEC standards which also need to be met for rotating electrical machines. We need to also take care about IP code, especially important for marine applications. Another standard for rotating machines are for AC generators, for reciprocating internal combustion, engine-driven generating sets. So this is specified standard for discussed generators. Thank you a lot for attention.